Hello everyone, this is your math lesson for Thursday, March 19th. You should have this page in front of you. It should be the next one in your book. We have perimeter and circumference, page 249. We're just going to do front and back of this page. This should be kind of a quicker, easier day. We've already talked about perimeter before. Perimeter is what? The distance around a figure. Doesn't change in polygons. Okay, polygons are the same. So we are adding all of the sides, even if they're different. If they're the same, you're going to add all the sides, and that's going to be the perimeter of that shape. So let's look at, so this shape on the screen that I have here has a side of 12, this side of 8, and this of 5. So if I were to want to find the perimeter of this shape, all I would need to do is do 12 plus 8 plus 5, and then that would equal my perimeter. Simple, right? So it's the same for when you have different size shapes also. So works for the triangle. Now look at this purple one here on your page. They only give you one number there. They say they give you a 3-inch. So how do I know what the whole thing is going to be? It's because that's a regular polygon, right? Regular means all of the angles are the same. So all the sides are going to be the same. So I count the sides, 1, 2, 3, 4, 5, 6, which I know it's going to be a hexagon if it's 6 sides. So I'm going to do 6 times 3, and that'll be 18 inches, and I'll know the perimeter of that. Now for these, all you need to do is take each number and add them, and you'll have the perimeter for each figure. Simple, right? Now, circles are a little bit different. Remember, circles are not polygons because there's no line segments. So circles work a little bit differently. Whoops. Go back here. Circles work a little bit differently. So look at 6 through 9 with me here. They want us to estimate the circumference of the circle. Circumference is the word for the distance around a circle. So same as perimeter, but for a circle, we call it the circumference. There's a formula for circumference. For circumference, we use what's called pi. And it has a little symbol, and you'll see that on your page here. I couldn't find it on my computer. So you look at the little symbol there. It almost looks like a little table, okay, with that kind of squiggly top. And so pi is 3.14, blah, 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 has lots and lots and lots and lots of numbers out. Some smart person figured it out, but we round it to 3.14. Well, for this lesson, they just want you to round 3.14 to 3. So you don't even have to worry about the decimal part, just 3. So for every circle, this is the formula. It's the same way. For every circle, you're going to multiply the diameter, which is the distance across the middle, this part right here, okay, times 3, which is what we're estimating pi at being. So for this circle, if it has a diameter of 5 all the way across, then I'm going to say circumference equals 3, which is my rounded pi, times 5. And that's going to equal 15 inches. Simple, right? So you're just going to take the diameters that they give you there, and you're going to multiply each diameter times 3 because we're rounding. We're not going to do 3.14 yet. We're just going to do 3. Now let's look at the back. Okay, at the back there are different ways of comparing figures. And we have 3 different ways listed there in the box at the top of your page. You see similar figures, and there's a similar for that. There's a symbol for that, which is just a little squiggly line. And then congruent figures, which is an equal sign with a little squiggly on top. And then underneath that it says that they're comparing line segments. So all congruent basically means equal. But for a figure, they're not always going to be exactly equal, so they call it congruent, just to allow for a little bit of error. Similar means they're the same shape, but they're different sizes. So for these right here, this one is going to be congruent, right? And the little symbol that we're going to draw for that, we're going to draw two. Let me see if I can do it here. I'm going to draw two lines like an equal sign, but I'm going to put my little squiggly right above it. And that means congruent. They're the same size, they look the same, but there could be a little bit different, so we're going to call it congruent. The next one, down here, let's see here. Let's get to the bottom of my screen. Why is it not? Getting to the bottom of my screen. Don't know why it's doing that. Okay. Let's say, let me go over here and just show you. If I have two shapes and one is big and one is not as big, but they're the same shape. Okay, they're the same shape but different sizes. We're going to call this similar. And for similar, all we do is just one little squiggly line in the middle. They're kind of the same, but not really, because they're different sizes. So that's the similar. Kind of, not really. Congruent has an equal sign underneath it. You're getting a little bit closer there for congruent. Okay? So you should be able to figure out 10 through 13 based on that. Now let's go backwards here. Now, in the next part, we're going to talk about 3 different ways to position figures. Again, this is going to mess up on me and not let me scroll. Let's see if I can scroll. Let's just bring this figure over here. Okay, so for translation, so we have 3 different ones: translation, rotation, and reflection. Translation, your figure, you see your pictures right there. You really don't need me for this. You can see this pretty clearly on your page. Translation is your figure just simply slides to another position. It doesn't turn, it doesn't change, size doesn't change, it just slides over. Okay? It translates. It was here and now it's over here. So that's translation. So pick the picture down there, 14, 15, or 16, that goes with translation. Just a straight line kind of down. Okay? Now, rotation. Let's move my figure up a little bit so you can see it. Rotation means that it has now turned. So we have this line like this, a little arrow. It has flipped over to the side a little bit. So you see if I pull this back up, okay, so it has rotated. So pick the ones down there at the bottom that you would say has rotated, has turned. Now let's look at the last one, reflection. Reflection is like when I look in a mirror. That's why when I hold this up, it's backwards to you because you're getting a mirror reflection. It's when you look in the water and you're upside down, okay? It's almost as if you were folded in half. So that's your reflection. So just like this triangle here is almost looking at itself. So the reflection is flipped across a line of reflection is how your book puts it. Okay, pretty simple lesson today. Should have kind of flown through that, Hope it went well for you. Make sure as you're going through these that you're reading those boxes. These books are really designed for you to be able to kind of teach yourself and understand and review. So read each one. Don't skip over that and then get down and say, well, I don't know what to do. Okay, go back, read over it. I know this is a time kind of that we're practicing, kind of teaching yourself a little bit, but it's good for us. It's good for your brain to know how to walk through things and kind of talk yourself back through it. Okay, have a good day.